Hello, everyone. I'm Harika, and I'm from Team 4. We did a project on Netflix data analysis using Azure Cosmos DB multimodal. So here are my team members, Kunal, Shravya, and Raja. So getting started with the objective of our project. To study the statistics of different shows and movies that are released in Netflix. And also because, with the pandemic and everything, we started looking for more alternatives where we can, watch and relax at home. So we thought Netflix would be a great platform to study its statistics. So we also in the project have constantly concentrated to evaluate and compare all the materials that are released on Netflix. And we also try to understand what are the trends and patterns in the data that we had. So we used, of course, Azure Cosmos DB for data access and analytics. And then we finally used Power BI to visualize the data. Moving ahead. So this is our sample data set. So our data set is a CSV file. So we have like a show ID, what type of a show it is. Is it a movie, TV show? What are the titles of it and who are the directors? What are the casts? Country it released, the date it's been added, the release year, what are the ratings, what is the duration, and so on. So basically, with the CSV set, at the end of the project, we tried our maximum to bring out the underlying meaning of the CSV file here. Moving ahead to the architecture diagram. So like I said, we initially had like a CSV file. So we were looking for several options of how to bring it to Azure Data Factory, and Amazon S3 was one of it. So for people who don't know what is Amazon S3, Amazon S3 is abbreviated from Amazon Simple Storage Service. And then we further moved to AWS Lambda, and then we further moved to Azure Data Factory to create pipelines and triggers. And then from there to Azure Cosmos DB, and then Document DB and Power BI and Gremlin respectively. So the ETL steps for both the Cosmos, for the document and the graph DB will be taken care by Kunal and Shravya respectively. Kunal, over to you.
Thank you, Harika. Can you go to the next slide? Yeah, next one. Right, so I'll be explaining how the implementation of document DB is done. So the first step, as Harika mentioned in the architecture diagram, that we are using AWS services as well as the Azure services. From AWS, we are using S3 and AWS Lambda. S3 is the first place or landing place where the CSV file would come. Once we have a new CSV file in the input S3 file, it will be a lambda function will be triggered, which is the second step. That lambda function will have a code to process that CSV file. There, if you had a look at the CSV file, we had columns like listed in, or country, or the cast and director. These are all comma separated columns. Like there are multiple values in them. Countries can have United States, India, with a comma separation. We are processing them as when we get that data as document DB or JSON in JSON format, we're converting that comma separated value or multi valued cells as string of array. That is one processing that we are doing. We are also working on the dates that we have in the data set. That is because there are many records where dates are not properly populated. So we are converting that as well. Whenever any new file comes up, if the date is not in a particular format, that has been converted as well. So all this logic is comprised in the lambda function. So once that lambda function runs, lambda function is basically triggered by any file being created in the input bucket. Lambda function runs, and then it creates an output JSON file in the S3 output bucket, just to name that bucket. So this is how the AWS part runs. Lambda function basically creates a JSON file in the S3 output bucket. After this, we have Azure Data Factory pipeline, which picks the data from the JSON file from the S3 output bucket, runs the pipeline, a copy data pipeline that we have in Azure Data Factory, and then puts it into the Cosmos document DB. That's the part 5 and part 6 of our architecture for document DB. Yeah, so part 5 is the pipeline picks the S3 output file and loads into Cosmos DB. And finally, that Cosmos DB is further connected to Power BI for analysis. Next steps, I guess we have a few screenshots where we have input bucket and output bucket. This is on the S3 AWS side. Next slide. This is a screenshot of how the Lambda function is configured. We have an S3. Can we go to the next slide? The previous, yeah. So we have an S3 bucket as a source. So whenever any new file comes up, the configuration is made such that the Lambda function will be triggered automatically. The Lambda code, we just have a small part of that Lambda code below, which again runs or has a logic, as I said previously. Next slide. So this is our data factory pipeline. We didn't use the pipeline or the data flow elements because all the processing and transformations that we needed, we had performed them using the Lambda function, the Python code itself. So this data factory just included, or just we just needed to pick that data from the S3 bucket, output S3 bucket, and put it into the Cosmos DB. So that first element, copy data, the source is S3 bucket, and the sink is Cosmos DB document database. Further, after that, we delete the file that is present in the S3 bucket, the S3 output bucket. Next slide. And this is a demo or a picture of how the data looks in a document format in the Cosmos DB. So if you, I'm not sure if it's visible to all, but there are a few fields like director, caste, country, date, all these things, they are transformed basically. I think we do not have multi-valued example over here, but there can be. So if you see the director, there is just one director over here. In the CSV file, we had all the directors which were separated by commas. What we had to do was, in the Python code, we wrote a code such that these multi-valued or comma separated values would be converted into strings of arrays. This was useful to us when we did the Power BI analysis, because if we kept them as comma separated values itself, the analysis was not properly done. So for the countries as well, whenever we want to see if how many movies or TV shows were created country wise, if this transformation was not done, that wouldn't have shown properly, that visualization. So this was necessary. Again, the date as well, there were some anomalies in dates. For some records, we had to transform them as well to get them into the perfect format, and generalizing all the records in the same date format. Next slide. Can we go to the previous slide? I just wanted to explain about the data refresh as well. So our data set has ID column. The first column, if you see the field, which the values for which are S1, S2, S3, and so on. So because that is the ID field, whenever any new CSV file comes up in the S3 bucket, the Lambda function creates the JSON file, equivalent JSON file. And after that, whenever a data factory job runs to put the data into Cosmos DB, if the ID is already present in the document database, it will just update it. So if ID S1 is already present in document database, and suppose the rating changes, so only that rating will be changed, that field will be changed, and not the entire new document will be created with the same ID as previous. So that happened. That was possible due to the ID field that we had. Next slide. And this is just a screenshot showing that the Cosmos DB, that the Azure Data Factory, we had a trigger in place to run that every 15 minutes. That can be changed again as well. to run every day. So this can be done as a batch processing as well, where a new CSV file probably which would come every day, including TV shows and movies, and then the Azure Data Factory runs every day to pick that data from S3 bucket into Cosmos DB document database. Next slide. This is the screenshot of the trigger that we had. We can have it to run as every 5 minutes, 15 minutes, or every day as well, depending on how the what the frequency of the data incoming data would be. Next. Yeah, so that was about document DB. The graph database part will be explained by Shravya.
Yep. Thanks, Kunal. Hello, everyone. My name is Shravya. I'm here to explain about the graph database implementation of our project. So if you can see, this is basically the graph database diagram that we are currently showing. This basically shows the various nodes that we are creating from the data set that we have, and the relationships are built from the joins of the ERD. To explain the implementation part from the CSV file to the graph database, we followed a set of steps. Can you go to next slide? So basically, we started with creating a graph database in Azure Cosmos DB. This was necessary because we had to programmatically handle creation of nodes and edges. And the biggest challenge that we faced during this implementation was like moving the data from CSV file to the graph database, was defining the nodes and the relationship between the nodes. So we had to create a Python script. We have written a Python script which programmatically handles the creation of nodes and the edges. The second step is load the CSV file into a S3 bucket, which basically plays the role of data storage for all the versions of the CSV file that we are going to upload. Next. So just to handle the pipeline, we have created a Lambda function from the source of the Python script that we have written to to programmatically generate the nodes and the relationships. Next slide. Next. So what this Lambda function does is, whenever a new version of the CSV file is uploaded to the S3 bucket, this Lambda function is attached with a trigger. Whenever a new version of the CSV file is uploaded, the code in the Lambda function gets executed, and the nodes and the edges are automatically will generate a Gremlin API query, SQL query, and it will run it in the Cosmos database, which will automatically generate the nodes and the edges. And we have also handled the data refresh part of this implementation. For example, if there is a show that's already available in first version of the CSV file, if there is any data change, for example, as ours is a Netflix database, if there is any duration change of one of the particular shows in the second version, this will when this new version of the CSV file is uploaded, the Lambda function, when the Lambda function is run, the data gets updated in the Cosmos DB as well without creating the new nodes. Can you go to next? So the screenshot shows the configurations of the S3 bucket. So S3 bucket is created with the versioning enabled so that we keep a track on all the CSV files that are uploaded to the S3 bucket. For reference sake, in the future, like whenever you want to see what types of changes that are done to all the CSV files, we can have a track on it. Next slide. So this is basically a Lambda function screenshot of the Lambda function configuration, which shows the trigger being attached S3 to the Lambda function. Next slide. Yeah, these are some of the nodes that were created in the Cosmos DB graph database using the Lambda function. This screenshot shows that. Next. So the data refresh part is showed in the screenshot. If you see for the show S1, the duration here shows is 90 minutes. In the next slide, the duration is updated to 120 minutes. And this is handled through the pipeline. Next slide. Yeah, that's all about it. And my teammate Raja will explain about the visualization.
Thank you so much, Shavya. Yeah, so this is our visualization charts. So the first of all, if you see there is total content, which implies there are around 8,807 contents in our data. That includes movie as well as TV shows. And in the second chart, if you see there is a division of how many movies and how many TV shows are there. And if you see movies are around 69% and TV shows are around 30%. And there is a year-wise content chart as well. And if you see from 2010, the amount of data is increasing until around 2018 or so. And then there's a drop in 2020 and 21. And this is possibly due to COVID, where there is not many movies that are getting released. And if you see, there are many categories that our data is consisting of, and there are international movies that has highest TV shows and movies, that is 2752, followed by dramas and comedies and so on. And if you see, there is content by country as well, which is a geographical representation of our data. And there is a rating chart as well, where in Power BI, if you click on any specific rating, the data shows for that particular rating. So this is our visualization charts. This marks the end of our presentation. And if you guys have any questions, I would like to answer them. Thank you.
Hello. First of all, like very great implementation. I understood what you are doing, and also the great presentation as well. And the visualization is also very nice. So my question is, like, you are doing the same, like what I have done is like created those nodes and edges automatically, and you are doing the same thing in Lambda function, I guess. So can you like explain more or show the code, like how you are doing that, and like getting that new nodes or new edges into your Gremlin API?
Yeah. Harka, can you stop sharing? I'll share my screen.
Yeah, sure.
So can you see my screen? Yeah.
Yeah,
I
sure.
Yeah. So this is a Python code that we have written to handle creation of nodes and edges in the Cosmos DB using Gremlin API. So first of all, we read the CSV file from the S3 bucket, and we check if that particular node is already available in the Cosmos DB. If it's not available, then we'll go ahead and create all the nodes, I mean, all the necessary nodes for the directors, cast, shows, type, and then go ahead and define the relationships for all the nodes. If it's not available, one of the challenges we faced is to figure out the edge relationships. I mean, the edges that were connecting the different types of nodes available in the database. For example, there is a director change or cast member change for 2 versions of the CSV file. Then we had to delete all the relation if the node is already available and there is a data change in the node types. Then we had to delete all the relationships and then recreate the relationships, new relationships. Yeah.
Yeah, that answers my questions. Thank you.
Yeah, sure.
Any other question or comment for Team 4? Team 4, I have a question for you. I'm just curious, what is your thought process in including both AWS and Azure in your architecture?
So basically, we were trying to gain information or knowledge about both the cloud types. That was one of the reasons. The other reason was also that we had tried using Azure functions as well and Azure Logic Apps, but the free version of it, we are not sure. We were not able to configure it properly, or the end-to-end configuration was not happening properly. So we thought, let's just go with Amazon or AWS services. It was easily possible for us to configure that, have the data set passed on from the Lambda functions into S3 bucket in the required format that we wanted. So I would say, yeah, we would say these were the reasons we we thought of using AWS as well in our architecture, and that helped us understand not only the Azure part, because in the course overall we did learn about AWS, the Azure, sorry, Data Factory, Cosmos DB, Logic Apps, but through this project we also got to know more about AWS services like AWS S3 and Lambda.
Excellent. So were you able to get the AWS services free, or did you pay for any of those services?
No, we get AWS services free as well. Like we get Azure services for a month, so
Oh,
we use that those credits. Yeah.
excellent. It's not uncommon, not unusual that a company has a hybrid environment. Okay, so great work and great presentation.
So, Professor, to add to what Kunal told, if you see in our presentation, we have programmatically handled creating the nodes and edges. So for that, we had to write a Python script. And when it comes to the efficiency part, Lambda has always been on the top when running the code. So that was one of the reasons why we considered AWS, and it was hassle-free using Lambda functions. So yeah, that's
Excellent.
one of the
Right.
reasons why we had to choose AWS.
Right.